Algebra 1, Lesson 36. We are looking at proportions, and we need to be able to write and solve them based on some word problems. So big vocabulary terms in here. We're talking about some geometry because similar shapes, we have the same shape but a different size. So those angles are the same, the shape is the same, but the side lengths are different. Congruent, we are talking about same size, same angle, same shape. Scale factor, this is the ratio of the side length of the figure to the side length of a similar figure. Scale drawing, we are saying that that's a drawing that reduces or enlarges the dimensions by a constant factor. So being able to say, well, this room, we're going to put on a small piece of paper and reduce the size so that it fits. And scale, this is just a ratio showing the relationship between a scale drawing or model and the actual object. So when we look at similar triangles, we can say, well, triangle ABC is similar to DEF because angle A is the same as angle D, angle B is the same as angle E, and angle C is the same as angle F. Okay, so we have all of the same angles here. And then when we look at the side lengths, we want to make sure that those are similar. So we can say, all right, AB corresponds to DE. Okay, they are corresponding, they are alike sides. BC is similar to EF, and AC is similar to DF. Okay, these are corresponding sides, and we say they don't have to be congruent, but they do have to be proportional, saying that the ratio of all of the pairs must be the same. So if we compare AB to DE, BC to EF, and AC to DF, all of these ratios should be the same, which when we look at the different numbers, we would say, yeah, they are the same. We would say, okay, well, if we're looking at AB to DE, that means that we have two. Oh, let me get a pen. We have 2 to 1. AB is 2, DE is 1. So we have 2 to 1. We would say, okay, BC to EF. Well, BC is 4, EF is 2. So that ratio is the same as 2 to 1. And AC to DF, 5 to 2.5. All of those ratios reduce to 2, which we can say, oh, the scale factor from the small one to the big one, we just multiply by 2. Those ratios are the same. So let's look at another example of some similar figures. So if we have PQRS similar to WXYZ, we want to figure out the measure of angle Q and measure of angle W. Well, like we said on the other page, those corresponding angles are going to be the same. So if we are looking at measure of angle Q right here, well, that's going to correspond to this one right here. So the measure of angle Q is 80. And the measure of angle W, okay, we have right here we need, well, it corresponds to measure of angle P, which is 120. Okay. Let me just erase a little bit here. All right, so we have these angles now. Let's figure out some scale factors. Okay. Find the scale factor of PQRS to WXYZ. So we're saying from the big one to the small one. We want to figure out, okay, these ratios is where we're going to find our scale factor. So let's figure out some ratios. If we say, okay, I want to figure out WZ to PS, WZ to PS, I picked those because we actually have measures for those. We would say that's 2 to 3. Okay, so we would say going from the big one to the small one, I multiply by 2 over 3. Now what if I wanted to go back? Well, I would flip these and say PS to WZ is 3 to 2. And what you notice about these numbers is they are reciprocals of each other. That is going to happen whenever we go from one similar figure to the other and back. Use the scale factor to find QR and ZY. Well, if we're finding QR, okay, we're looking at this side right here for A. All right, let me erase those. My board is really freaking out today. we need to use the scale factor to go from the big one to the small one. Or, sorry, we want to go from the small one to the big one, all right? So we know that the corresponding side is xy. Well, the side xy has side length of 5. Okay. So xy is 5. So I would say, okay, to go from xy to qr, I would need to multiply by 3 over 2. That's a scale factor from one to the other. So I get 15 over 2, which is the same as 7.5. Now, when we want zy, that corresponding side is sr, which is 6. So we would say, well, going from big to small, I would need my 2/3. So I multiply by 2/3 and get 12 over 3, which is 4. So we can use those scale factors to figure out some missing side lengths. Now, are these triangles similar? We need to make sure that the ratio is the same for everything. So if I'm going to use corresponding sides, maybe I see that, okay, 18 corresponds to 12. And 21 corresponds to 14. And 12 corresponds to 8. Well, if I reduced all of these, I would see, well, that's 3 over 2. And 3 over 2. And 3 over 2. Well, that means that, yes, these are similar. And our scale factor, we would say from small to big, we are multiplying by 3 over 2, which means going back, we multiply by 2 over 3. Okay, how big is this Wonka bar? Well, we can also use proportions to solve these problems as well, not just a scale factor. So we could use our dimensions, and let me scroll so you can see this other dimension that we have. Okay, so we have 3 by 6 and something by 36. So let's set up a proportion. So we can say 3 to 6 is the same as x to 36. Or we can set it up and say, well, 3 corresponds to x, so 6 corresponds to 36. Well, regardless, you can cross multiply, you can figure out that 6 over 36 is 1/6, or 3 over 6 is 1/2. Regardless, you find that x is 18. So this huge Wonka bar is 18 inches by 36 inches. What we're doing when we're setting up proportions, a good way to go about it is saying, well, I'm going to put them into ratios of corresponding sides. So I would do figure 1 width to figure 2 width and equal that to figure 1 length over figure 2 length. So that when I get to something like this, I can use my proportions to solve. So it even helps us by helping us set up. So it wants us to do xy, so 18 corresponds to AB, 6, and yz is 30, corresponds to x. We don't know what it is. Well, we can do one of two things. I'm going to first reduce this to 3 to 1. So the only way for this to be proportional is 3 to 1 has to correspond to 30 over 10. So x equals 10. So we can set up these proportions to get an accurate representation of these side lengths. Let's do some practice problems. A map has a scale of 2 centimeters to 14 kilometers. Evanston and Wilmette are 6 kilometers apart in real life. How far apart are they on the map? So we would set these up and say, well, 2 centimeters goes to 14 kilometers. So I have the kilometers, so I'm going to put it in the same spot. 6 kilometers is the same as x centimeters. And in this one, let's cross multiply. And we get 14x is equal to 12. So I divide by 14. And I get that x is equal to 6 over 7 centimeters. 6/7 of a centimeter is x. All right. Let's look at our statue. A statue that is 10 feet tall casts a shadow that is 16 feet long. Find the length of the shadow of a 4-foot cardboard box. So I would say, well, I can correspond my 10 feet of the statue to our 16 feet of shadow. So 10 to 16. And then since I have 4 foot of cardboard, that corresponds just like the statue, so I'm looking for X amount of shadow. And I can do a couple different things, but let's cross multiply again. But I'm going to reduce and say this is 5 over 8. So that I do 8 times 4 is 32 is equal to 5x. Divide by 5 and get that x is equal to 6.4. So the shadow of the cardboard box is 6.4. All right, next one. A model of the high school has a scale of 3 inches to 60 meters. If the high school is 514 meters wide, how wide is the model of the school? So we do 3 inches to 60 meters. And since I know the meters, I put 514 meters here, and I want to know how many inches. So I'll reduce over here 1 to 20, and I'm going to cross multiply to say we have 20 equaling 514. Oh, sorry, 20x equals 514. So when I divide by 20 on each side, I get that x is equal to 25.7 meters. Inches, sorry. We're looking for the scale amount, and it's going to be 25.7 inches. All right. We are given these two triangles, and we need to put some information on the sides of them. So ET is 2. TH is x plus 1. Let's see, EH is 4. OR is 12. PR is x plus 7. And I want to know what is TH. Now TH, I'm given some information, but I need to figure out what x is to find the actual amount of TH. So I could set up a proportion to say, well, 2 to x plus 1. Oh, sorry, that's not a good example. Let's not use 2 because I don't have any information on the other side to help us with that 2. Let's use, so 4 to x plus 1 is the same as 12 to x plus 7. I could have set up this proportion in a lot of different ways, but this is one of them. And I need to cross multiply. So I end up with 12 times the quantity x plus 1 and 4 times the quantity x plus 7. So I need to distribute in both of these cases to get 4x plus 28 is equal to 12x plus 12. And I need to get my x's on the same side. And I get 8x plus 12 equals 28. I'll subtract 12 and get 8x is equal to, 16. So x is equal to 2. Now I figured out what x is. Now I have to plug it in here and say, since x is 2, then TH equals 3. And I could also input that over here and say x is 2, so 2 plus 7 is 9. So PR is actually 9. All right, we have a couple more practice problems. In this one, remember to set up your proportion. So I would say something like, 40 is the same as 48. Remember, I'm going my corresponding sides since these are my hypotenuse of my triangle. So 40 to 48 is the same as something to x. Now, since I started with 40, I'm going to put x on top, and let's see which one it corresponds to. Well, JK is going from this angle to this one, so I need to go from this angle to my 2's. So I'm looking at the 24. Well, if we say, all right, 24 times 2 is 48, so something times 2 is 40. So x equals 20. Next we have an Oompa Loompa. He shrunk himself using Wonka vision, so his TV height is 3 inches and his TV shadow is 5 inches. If the Oompa Loompa's original shadow was 60 inches, what was his original height? So we could say the TV height to TV shadow is the same as, it should be the same ratio as his original, let's see, his original shadow is going to go on the bottom as 60, so I want his original height x. So I'm going to cross multiply and get 5x equals 180, divide by 5, and see that x equals, let's see, the Oompa Loompa is going to be 36 inches. Okay, 36 inches in reality. 2 more examples and then we'll be done. How tall is Phil the groundhog? So we are given that the tree has as 18 feet tall, shadow of 6 feet, and the shadow of our groundhog is 1 foot. So I say 18 feet is the same as 6 feet. Okay, so real height to shadow, so real height x to shadow 1 foot. I cross multiply and get 6x is equal to 18, so x is 3. The height of our groundhog is 3. And lastly, my parents redid their kitchen this summer. The scale drawing of the kitchen tabletop has dimensions of 5 inches and 2.5 inches. If the scale factor of the actual table is 1 inch to 18 inches, what are the dimensions of the actual table? Well, we have this ratio of 1 inch to 18 inches. And that ratio needs to stay the same. So if I now have 5 inches on the drawing, then I would cross and say that x is equal to, well, 5 times 18 is 90. So our width is 90 inches, and I do it again, 1 over 18 is equal to 2.5 over x. So x is equal to 45 inches. So we have a table that's 45 inches by 90 inches. Well, I hope this is helpful for studying and for your homework.